Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2017 Maths Methods Exam 2 Northern Hemisphere multiple choice section. And yeah, let's go through this paper. Before I start, like always, guys, if you want private tutoring, you can always email me through this email. And yeah, we can have a talk, through the physics, chemistry, specialists and methods. So yeah, okay, so this exam right over here was actually not the past accreditation point through 2016 to 2022 study design. So what it means is this is not not the last study design, but it's like twice the last study design. So it was the old and older. So what's probably it's going to have is, one of the old study design, one of the points it had is hypergeometric distribution, which is another probability stuff. I will tell you that concept, but you don't need to, I'll tell you to not use it because it's not in your exam for the future students. So yeah, let's walk through this paper. All right, question 1. The gradient of the line that is, the gradient of a line perpendicular to that line that passes through this and this is what? Very nice and easy. So we know the gradient is, let's say this is x1, y1, x2, y2. So we know it's y2 minus y1 over x2 minus x1. So it's going to be -6 minus 0. 0 minus 3, which is 2. Now, we know that the gradient perpendicular is -1 over the gradient, which in this case is 2. So it's -1 over 2. Choose A as your answer. The function with the rule f of x is given by this has a period of what? So it's a sine function. So we know that the period is 2 pi over 1 over 4, which is 2 pi times 4 over 1, which is 8 pi. Choose E. The simultaneous linear equations this and this have a unique solution only for what? So this is a very typical question, and this is how you would do it, the quickest method. So what I would do is, in my cast, I would write determinant this, and I will use a matrix here. So I want you to look at the first equation, and what is the value for the x? So can you look at the x here? What's the value? Well, it's m, so we'll write m over here. What's the value of the y? It's 7. We don't have to worry about the equal sign. Yeah. And what about for the second equation? Well, what's the value of x? It's 7, so we'll put a 7 here. And what's the value of y? It's m. Okay. And we want to let the determinant equal 0. So let's do that in our calculator. So we want to determinant of, use this over here. So m, 7m. And we want to let that equal 0. And we get this. And we want to solve for m. And we get these two values here. Because we want to find a unique solution, it will be all reals with the exception of these 2 points over here. So your final answer should be C. It says all reals with the exception, -7, 7. Perfect. The graph of the function from 0 to infinity, where f of x is given by this, is reflected in the x-axis and then translated 5 units to the right and 6 units vertically down. Whichever following is the rule of the transform function. So, okay. So what we've first done is we reflected it in the x-axis, so it'll be negative f of x. So it'll be -4, x 1/3. And when we translated 5 units to the right, so we say negative f x minus 5, -4, x minus 5, 1/3. And then we've 6 units vertically down, so it'll be negative x minus 5 minus 6. So it'll be -4, x minus 5, 1/3, minus 6. Which one does that look like? Not this one, because I have both positive. Not this one too. It's D. Perfect. Whichever following is the inverse function of this. So it's going to the negative side. Be careful, this is your actual domain of this function. So what I'm going to do is I'm going to interchange x and y. So x, 2, 3 minus y, plus 1. So it'll be x minus 1, 2, 3 minus y, 2, x minus 1, 3 minus y. So squaring both sides, so it'll be x minus 1 squared, 3 minus y. Y is 3 minus 4, x minus 1 squared. So which one does that look like? This one looks good. This one's nope, it's supposed to be a 3. This one looks good. This one absolutely wrong. And okay, so these look right. So now we just need to find the domain of the inverse. So to find the domain of the inverse, it's the range of this original function right over here. So, oops, let me just write this off. So let's do that. So I'm just going to graph it to make my life easier. So I'm going to go on graph, and I'm going to just say, what is 2 square root 3 minus x given, plus 1 actually, yeah, plus 1, given that we know it's less than 3, given that x must be less than 3. And we get this. So we can see that the domain, the range of this function, which is the domain of the inverse, is what? Well, it looks like it's approaching 1. So we can say, So we can say 1 to infinity. It's going forever. So yeah, 1 to infinity. Which one would that look like? C is the answer. The other one's, yeah, not this one. Sorry guys, my thing just stopped for a second. I don't know. Yeah, so yeah, it cannot be negative 8 to negative infinity 3. It can only be 1 to infinity. Perfect. Question 6. So let f of b this, where d is the maximum domain, which will follow the equation with the asymptotes of the graph. Very easy. Use your calculator. So what I would do is say, on my calculator, I would say expand this expression, which is 3x minus 5, 2 minus x. Perfect. So here is, this negative 3 is your y equals negative 3 is an asymptote. And this over here, if we solve it for 0, x equals 2 it means. So, and x equals 2 is another asymptote. So x equals 2 and y equals negative 3. Choose B as your answer, yep. Perfect. So x equals 2 and y equals negative 3. Perfect. The graph of y equals kx minus 2 will not intersect or touch the graph of this when? Okay, what I would do is I would make them equal to each other. So x squared plus 3x equals kx minus 2. And bring the left-hand side to, so actually the right-hand side to the left-hand side. So it will be plus 3x minus kx plus 2 must equal 0. So it'll be x squared plus 3 minus k x plus 2 equals 0. Now, this is an actual quadratic, and what we want it to, for it to not intersect, we want to let the discriminant be less than 0. So it will just be, so we want b squared minus, b squared minus 4ac to be less than 0. So what's our b? Well, it's 3 minus k squared minus 4, 1, 2 must be less than 0. So writing this in your calculator, solving for x, so solve, for k, sorry. 3 minus k squared minus 4, 2 less than 0, comma k. And we get this. So the answer should be A. Perfect. Question 8. Part of the graph of the function f is shown. Which of the following is the average value of the function over the interval negative a to a? So we're going from this point over here to this point. We want the average value. So we know that the average value is 1 over a minus negative a over the integral from negative a to a of f of x. Now, this here simplifies to 1 over 2a. And this over is just the area under the graph from negative a to a. So if we look at over here, so we're going from here, so this area over here and this area over here cancel out. Can't we see that? They're both equal. So they will cancel. So that's good. So they will equal 0. So we just need to find the area from this now. This square actually. It's a square, yeah, because it has this. This is a and this is a. So a times a is a squared. So that'll be a on 2. That should be your average value. Done. The range of the function this, f of x, is what? So we have a restricted domain, and we just need to find the range. Easy. Let's just use our calculator. So go on graph and say we want to find the natural log of x squared from, we're given the domain, so negative 0.5, given that x must be between 0, that's 1 point, and I'm just going to take the same thing over here and make another, but now from 0 to 2, so 0 to 2, but this point is included. Perfect. And yes, let's look at the range. Well, it's negative infinity to the max point over here. Well, the max point over here is at 2. So what is this over here, given that x equals 2, it's 2 log E2. So negative infinity to log E2, and it should be included because the 2 is included. So negative infinity to log E2 included, C is the answer. The tangent to the graph of y equals 3 sine 2x minus 1 is parallel to the line with the equation at this point, where x equals what? Easy. So let's find the gradient of this and let's find the gradient of this and equate them. So this will be dy dx is 6 cos 2x. And for this one, it's going to be dy dx equals 3. Equating both of them, it's just 6 cos 2x equals 3. Now I'm just, because it's a general solution, I'm just going to use my calculator. So I'm going to say solve 6 cos 2x equals 3, comma x. And we get these two general equations. Now, what do we see? Well, we can see that they're the same thing, but they just have a plus or a negative here. So let's just write them down. So we can just set them as x, 6, n. So 6n plus or negative 1 pi over 6. So just expanding that, we can get 6n pi plus or negative pi over 6. That'll be n pi plus or negative pi on 6. Which one does that look like? Choose A. Perfect. A bag contains 5 blue balls and 4 red marbles. A sample of 4 marbles is taken from the bag without replacement. The probability that the proportion of the blue balls in the sample is greater than this. Okay, so we want the probability that the proportion is greater than half. Okay, now we know the proportion is x over n. And our n value here is 4, not these two together. Remember, we are taking a sample of them. So yeah, your n value is 4. So what's this value over here, the half here? X over 4. So x equals 2, so we can rewrite this as x is greater than 2. Which, remember, it is pretty much, we cannot have what? Like, yeah, x is greater. So this can be written as probability of x equals 3 plus the probability of x equals 4. Yeah, because n equals 4. Now, because this is where the problem with this question comes from. It says without replacement. So this here, it tell you to use what we call is the hypergeometric equation. Now, you shouldn't learn this because it's not part of the study design anymore. But to do hypergeometric distribution for without replacement, it is pretty much. So let's look at. Okay, so we have 5 balls, so 5 blue balls. So right, 5 choose, and we want 3 of 3 white balls. 3 blue balls. So we write 3. We want to multiply by, now how many in total are red? So 4. And how many reds do we want? Because remember, n is equal to 4. It should be 1. Because, you know, because we want 3 balls and the other one that will be left is just 1 red ball. So write that over, what's the total of these two, which is just 9. Choose, and what's the total of these two, which is 4. That's for the probability of 3. Now, plus, we need to find the probability of 4. Same thing. So 5 choose, but now 4 times 4 choose. Now there will be 0 over n choose 4. So doing this in our calculator. So let's write that. We can say menu, probability, combinations. I'm just going to copy this combinations thing over here and say, okay, 5, 3 times, so 4, 1. Copy it here, so 9, 4. And same thing, so here would be 5, 4. Oops. 5, 4 times 4, 0. And 9, 4. And that gives you 5 over 14. Perfect. See, look, this question, you can do it with a tree diagram. I'm not saying you cannot do it, but for a multiple choice question, if you use a tree diagram, it will take you 10 minutes to get the answer, and it's going to be a mess. So that's why we use hypergeometric equations here, distribution. So look, I wouldn't too stress about this question if a lot of if students who are doing past papers for this year get into this question and don't know what they're doing, don't bother. I wouldn't stress about it too much because this question shouldn't come up in the exam. Yeah, so let's move on to the next question. Question 12. The maximum temperature reached by the water heated in a kettle each time is used as normal distributed with a mean of this and its standard deviation of this. When the kettle is used, the proportion of times that the maximum temperature reached by the water is greater than 98. Okay, that's not too bad. So we want the probability that x is greater than 98. Okay, so let's do it in a calculator. Just go on menu, probability, distributions, and this is, we want to use normal CDF. Our lower bound is 98. Infinity is our upper bound. And our mean here is 95. And our standard deviation is 2. And we get this over here, which looks like B is your answer. Yep, perfect. The probability distribution for the discrete random variable x is defined by this. The mean and the variance of the distribution respectively are, okay, so the mean is what? It's just these multiplied, so these multiplied plus these multiplied plus these multiplied, yeah. So let's just do that. So we're saying your mean is just negative a plus 2a plus 2b. That's your mean, so that would be a plus 2b. So these we can cancel them out. And for the variance, we know that the variance is your variance of x is the expected x squared minus your expected value all squared. So what does that mean? It means that we square this and we multiply. Same thing. We square this, we multiply. We square this, multiply. We square this and multiply. That gives us our expected x squared. So let's do that. So negative 1 squared is just 1, so it'll be just a. So yeah, that's useless, 0. Plus 2a plus 4b minus your expected value, which we've already calculated, which is this, a plus 2b all squared. So I'm just going to put this in my calculator. So what's a plus 2b, 2a actually, plus 4b minus a plus 2b squared. And we get this, and just expand it. And we get this. So yeah, B should be your answer, because this one is not expanded, so it has to be this one over here. Done. Question 14. The rule of a function with the graph shown could be what? Okay, so if I look at the midline here, it's at A. So it does, yeah, they all have A over here, so that's not good. What about the amplitude? It's A. The amplitude should be A. So this one's wrong. Okay, that's... And what about the period? Well, here it goes through one period, so we can say 2 pi over 2a pi a. So which ones have pi a? Nope, this one has pi over 2a. Not this one, and yeah. So we can only get D or E. So what I would do here is I would look at just D, for example. I'm just going to have a look at D and say, if I'm graphing this, so it's a sine. So if I just draw a nice sine with a period of this, so it would look like, let's say this is A. A, so it would look, actually, it would look like this, actually. Wait. So, then yeah, it's been also trended. So if I can really look at this over here and say, okay, say this is your max period, so, and this is over here, and if I'm drawing a sine, yep, and then what's happening is translated A units up, so we can translate this A units up, it'll be over here, and then we're translating it A units to the right. So if we're translating A units to the right, it will be over here. No, so it is wrong, or it can only be E. I just want to double check if it's E, because I'm not too sure. So E is, so a normal cosine graph with this period, so let's say it's at A, so over here it's at A, and it looks like, to here, this over here, and over here. Something like that. So, and we know that it's been translated up 1 unit, so we can say that, and then it's been reflected. So it's been reflected, if I can just really look at this like that. Aha, same thing, pretty much the same graph. All right, that's that. So choose E. The graph of f, where f of x is this, touches the graph of the inverse function at exactly 1 point as shown. The value of k must be what? So this is actually an, I've done an exam that's similar to this actually. So what I'm going to do is, because if they are, the inverse are equaling, what do we know? They, so we know at y equals x, we know that they're equal to it, like here. So we can say that we know that f of x equals x, we can say that. That's one equation. We can say also that the inverse of f of x must equal x. We can also say that the gradient, so the d dx of f of x must equal 1. It's the gradient of the line y equals 1, so because it equals to that. So if you draw this, the gradient's at 1. And we can also say d dx of the inverse of x must equal to 1. So just these 4 equations, I'm just going to define these functions. For example, f of x, I'm going to use my calculator. I'm going to define, and I'm just going to say ek times x. And I'm just going to go on menu, algebra, solve systems of equation for 4 equations for, let's say, x, and we want k, actually. That's the main point. So yeah, let's do that. So we're saying f of x equals kx. Oh, no, before we do that, we need to think. We need to get the inverse. So to solve for the inverse, we just say solve f of y equals x, comma y. So this is our inverse, perfect. Now let's do the algebra part. So this, that, for x and k. So we're saying f of x equals x. Oops. This over here, the inverse, equals x. The derivative of f of x must equal 1. And we know that the derivative of this over here, the inverse, must also equal to 1. Enter, and we get k equals to 1 over e. So, e is your answer. The area under the graph of y equals f of x between 1 and x equals 4, where f of x is greater than a half over the interval, is 8 units. The area under the graph of this over the same interval is what? So, okay, so if I was drawing a graph, say from 1 to 4, and we know that f of x is greater than half over the interval, or that interval, so this is half, so it's probably going to look like, I don't know, something like that, say like that. So we know that this area over here is 8. So, and we want to find the area of this, so it's just the integral to f of x. Wait, so it's going to be the integral of from 1 to 4 to f of x minus 1 dx. So 2, 1, 4 f of x dx minus the integral 1 to 4, 1 dx. And we know that this one over here, 1 to 4 f of x is what? Well, we know it's 8, so we can say it's 2. So 2 on 8 minus x 4, 1, 16, 4 minus 1, 16 minus 3, which is 13. Choose B. Question 17. A function f satisfies this equation. A possible rule is, okay, I'm just going to do it by hand, just quick, and say, let's try f of x as this. So we're saying x squared plus 2 is equal to x plus 2 plus x plus 4. I don't know. Let's just sub in 1. For x equals 1. This will be root 2. This will be root 2 plus, no, it'll be bigger. So no, these are not equal. So we can take that out. Let's choose the other one. So x squared plus 2, x plus 2, x plus 4. So this will be 2x plus 6. No, they're not equal. Next one, log 10 this. Okay, so we're saying log 10 x squared minus 1 is equal to log 10 x minus 1 plus log 10 x plus 2, so x plus 2 minus 1, which is just plus 1. Now, we know by log laws, they get multiplied, and they are perfect squares, so we can say just x squared minus 1. Yes, they are equal. Just see. Question 18, f of x is this, where a and m are non-zero real constants, and this is a factor of f dash of x, then which of the following must be true? I'm just going to use my calculator, so I'm just going to define f of x again, but now as x to the power of m times a times x. Okay, so I know that the derivative of f of x is this. And I know because x plus 2 is a factor, so it means if we sub in x minus 2, it should equal 0. So x minus 2, it's this. So we want to solve this. let it equal to 0, comma m. Okay, what the hell is this? M equals 2a. Only this one looks like the right answer, because yeah, they all look, these, I don't know, this is junk. So m equals 2a, which one does that look like? D is the answer. The first digit of each house number in a large address database is a random variable d. The possible values of d are from 1 to 9. And probability of d is given by this. Okay, equation. The probability of d is greater, so we want probability of d is greater than 8, given that d is greater than 7. First drawing a timeline, so let's say this is 7, this is 8. It's greater than this, greater than that. The intersection happens at probability that d is greater than 8, and over the probability of d is greater than 7. Okay, let me just rub this all off. So what we're trying to find is this over here. Right. Let me just say it right now, 7. Okay, so the probability, because we know the max is 9, we can just write this as probability of d is equal to 9, and this one is probability of d equals 8 plus probability of d equals 9. So let's just define the function. So we can say that, let's say, I don't know, let's say, yeah, like let's say f of d is given by log 10. So log 10, 1 plus 1 over d. Yep, so, and we're trying to find f of 9, f of 8, plus f of 9. That gives us this equation. Well, it doesn't look like none of the actual answers over here because they're all log base 10, but this is natural log. So let's control enter and just get the value. So 0.47. Let's try the first one. So it says 1 minus log 10. Let's try it if it's the same as what we got. So log minus 10. No, they are not the same. Let's try the second one. So the second one is just this over here. Again, also the same thing, but there's an 8 here. 0.47. 0.47. We got 0.72. And we got 0.472. Yeah, looks like B is your answer. Question 20. Consider the function from 2 into infinity f of x by this, where a is an element of Orioles. The maximal set of values of a for which the inverse exists is what? I'm just going to graph this. So let's say control N this. Go on graph. Okay. So x to the power 4 plus 2 x squared times a minus 4. Yep, so a minus 4 minus 8a times x plus 1. Okay. Okay, and we get this, and we know that f is between, so 2 to infinity. So what I'm going to do is I'm just going to sketch a relation, for example. Go in relation, x equals 2. And so this graph, so at this x equals 2 right over here, this right over here, this is going to show us we're only taking the right side of it. So right here, let's look at the first answer. So it says -9 to infinity, where -9 is not included. So if I say, let's say -8.5. -8.5. What happens? Well, it goes up. Down, which one? Yeah, here. So what can we see? Zoom in. All right. The way that I'll check, because it's very hard. I mean, you know, it's very hard to do a vertical line test. Yeah. Was it a vertical line test, actually? Was that... I believe horizontal line test, actually. Yeah, to do a horizontal line. One way that I would do it is I'm just going to look at the maximum and minimum graph. If there's a maximum and a minimum, it means it doesn't exist. So if I look at minimum here, okay, there's a minimum. What about a maximum? There's also a maximum. No, that's not good because it means that this is bending. So if you were doing the right, you know, the horizontal line test, it will fail. So A is not right. So we said -9 to infinity. So it must be less than, yeah, -8.5. What about the next one? -infinity to 1. So if we say -infinity, let's just try that. So let's put this to, let's say, no, -20. to be safe. So if I'm going to zoom out, what happens to the graph? Actions. Okay, take this and push it down. Does it go up or down? Where does it go? I think it goes up. Okay, it goes up. No way, that's bad, because the more negative we're going, we can see that this is coming out, and this is not good, because if you do the vertical line test, we are failing. So negative infinity, anything that has negative infinity is wrong. So we can just exclude A, B, and E now. So we can only C and D. So C says -9 to 1, both included. So if I say -9, let's try -9. -9, so it's down, down. Let's try to check if this is true. If I kind of zoom in, because it's saying included, I want to double check if there's a minimum and maximum here. So still minimum. Is there a maximum? Still there's a maximum. That's not good. It means that this is still curving. So C is wrong. Only D could be the answer. Let's just double check D. So it says 8 is included. -8 is included. Let's try to check that. So is that going up or down? Let's just zoom out. It's going down. Okay, let's just have a look here. Let's see if there's a maximum and minimum here. There's a minimum here. So we can see that the minimum is changing. So it's not 100% right. So here minimum, what about a maximum? No, there is nothing. Look, yeah, so we can see that there isn't like an actual maximum point over here. It's just a point of inflection. That's what it is. If I'm not mistaken, it should be a point of inflection. Just let's double check. Not intersection, inflection. Yeah, it's an inflection point. So, okay, that means that -8, what about, it says to infinity. To be safe, let's say this is to 20. What happens if let's just zoom it out. Let's say we go, let's just zoom out more. All right. Let's say we go down, more down. Oh, that's okay. Sorry guys, my recording just stopped. Yeah. So what's happening? So if we again, I want to zoom it in. Just have a look. No, this is good, because this over here is a nice slope. It's a if you do the horizontal line test, it passes. So yeah, I think just taking it to infinity just makes it, yeah. So it looks like D is the only answer here. Choose D. And yeah, guys, I hope you guys enjoyed this video. I hope it helped you in a way. And yeah, make sure to take care of yourselves and have a good day. Bye bye.